Okay, welcome everyone. Thanks for coming to my session. This is titled Cross-Platform Testing with Chef and DSC on Azure. I had the luxury of putting this title together way before all the announcements about DSC on Linux and cross-platforms, and so it's kind of threw this presentation up in the air when the announcements about Linux, DSC and Linux PowerShell sort of came to mind. So the major topic really is how we're integrating Chef with DSC across multiple platforms, what the development process looks like with Chef. So who's aware of Chef in the room? Who's using Chef in the room? No? All right, so about me. So I run a company called Pendrica, and basically the sort of story started about 18 months ago when I spotted a gap in. I've been a Chef user for many sort of years, since sort of maybe 2010-ish, so quite early sort of days of Chef. And at the time I was working as a consultant, ALM consultancy, doing sort of release management stuff and build and .NET and that sort of side of things. We saw there was a gap, really, that Chef wasn't as tightly integrated with Azure as it could be. So I started investigating kind of what was going on there, and found there was a whole bunch of activity on Chef and AWS, and didn't see so much activity on Chef and Azure. And sort of started to get involved, really. And as soon as I got involved, Chef community, for those of you who don't know, is a sort of wonderful community, and they're very, very welcoming. They're very keen to have new contributors. Very welcoming of sort of those contributions and pull requests. In the end, I've become an Azure MVP. I've written a book using Chef with Microsoft Azure. I was awarded the Awesome Community Chef Award, which is kind of an auspicious sort of thing. The book really talks about sort of the concepts of how we do provisioning, how we do configuration management, using infrastructure as code, what all the quality tooling looks like in that sort of Chef and Azure world. And I'll be giving away a couple of copies somehow in this session. So we're going to be sort of slide light, and then I'm going to sort of delve into some stuff. And kind of like for this to be somewhat interactive. I've got a bunch of stuff on my machine. You can take it sort of any direction you like. I am not, hold my hands up, say, I'm not a PowerShell expert. I'm a sort of, have a Chef background. I understand desired state, understand the processes sort of behind it all. But yeah, my real sort of focus is on how we integrate Chef with different platforms out there. So for those of you who don't know sort of Chef in the room, this is what this sort of ecosystem looks like of Chef at a very sort of high level. There's obviously your Chef server, but the focus of Chef development is in this sort of bottom section. So we do this thing called cookbook and policy authoring, and it's in a test-driven world. The Chef itself is a client that sits on the nodes, communicates with the Chef server, and there's a bunch of sort of premium features around that, sort of management, high availability and reporting. The core product itself is open source. So as I say, we are going to look at really this bottom section, where really the Chef ecosystem has a whole bunch of development tools in it that are used to develop policy and test policy before even deploying it. And we can use various clouds out there, AWS and Azure. There are various other sort of providers we can use as well. And to do our testing in the Chef world, we use a tool called Test Kitchen. And Test Kitchen actually spans a number of different worlds. So the Ruby community is sort of tightly engaged with Test Kitchen. The Puppet people use Test Kitchen, and you can interchange out sort of all the sort of components. So it's a framework built in Ruby for cross-platform testing to basically support chef cookbook development and to make sure that the changes we're making to our policy can be delivered in a safe way through to production. These days we have the inspec language, which is a BDD type language similar to how you might look at Pesta. Has certain similarities when you look at the types of language involved. It comes bundled with the Chef UK, and really the focus for inspec is not just in the sort of testing your infrastructure as code or sort of doing integration testing, but also to expand that into the world of compliance as code. So you can use a tool called Chef Compliance, which is part of the commercial sort of aspect of Chef, and use CIS profiles to test against your estate to verify that your estate is in the correct state. Too many uses of the word state there. Against those CIS profiles. So what does a kitchen test process look like? Well, there's actually only 4 stages to it. You have a create stage, converge phase, a verify phase, and a destroy phase. And all of that can be run in a single command called kitchen test. And because it can be run in a single command, it's sort of suitable for putting in CI systems. But this is really part of the development process for developing policy within the sort of Chef ecosystem. And one of the things I did, the sort of first or second thing I did is when I entered sort of the Chef community was build a test kitchen driver that works with Azure Resource Manager. And we'll sort of dive into probably how that looks and sort of have a little look at the code if anyone's interested. It's all Ruby based, I'm afraid. So the first phase, we talk to Azure, uses Resource Manager. The convergence, we use Chef. So when we say convergence, what do we mean? Well, we spin up a node, which is a VM of a certain type in Azure. Now we want to run our infrastructure code on it. So to do that, we need a Chef client, because that's the way the Chef's going to run in production. And Test Kitchen deploys that Chef client either over SSH or WinRM, depending on what platform you run. At some point in the future, I imagine it'll be SSH and your choice of shell, or there's going to be various options there. The actual convergence itself refers to the application of the state, the policy that's being described in the cookbook, to the node. We can then use the inspec through Test Kitchen to verify the state of the node and whether it's in our desired state. And then at the end of this, we can just throw away the nodes that we created. And so yeah, Kitchen runs in Ruby. All you need is a Chef DK. So when I was sort of thinking about what we were going to look at today, and I sort of thought, well, we have that bit blurb at the beginning, and then wouldn't it be great if we could automate the installation and configuration of PowerShell Core and DSC on Windows Server, Nano Server, and Linux distributions? Because when I go and look at GitHub today, I click on GitHub, I click do I want PowerShell? Do I want OMI first? Do I want DSC? I want to coordinate that into something that I can repeatably run. And bearing in mind, Chef is a complementary sort of tool to the DSC and Microsoft ecosystem, and you see Chef and Microsoft working sort of hand in hand, bringing these two together. I'm just a partner, so I get the sort of the sore end of customer problems. People sort of drag me in and say, "How could we do this? What would this look like if if Chef did this in the future?" And the good thing about Chef and the development kit and the tooling is that we can we can put together sort of demos and proof of concepts really rapidly. We don't have to even use a Chef server to demo what we are creating on our development environment. So I got to that slide and I was like, right, we're just going to stop there. And if I hit up command line, I get to sit down. So what we've got here, first of all, who's using VS Code in the room? Have we got any Atom users in the room? So if you're using Chef and Visual Studio Code, this is another little plug. If you go to the extensions tab, there is a Chef extension for Visual Studio Code, which basically adds all the snippets for all the built-in resources that are in Chef. And it also does sort of built-in linting on the code, so it does Rubocop testing. If you're in sort of from the Ruby background, you'll know what that means. And it can also run a tool called Food Critic, which is a static analysis tool that looks at chef cookbooks to determine whether you're falling foul of any sort of good practices. I refuse to say best practices. No, it's just static analysis in the form of it's sort of pattern analysis, basically on the actual recipes themselves that you develop. So for today's session, I built this cookbook, and it's very easy to create cookbooks in the chef development world. You just do chef generate cookbook and then a cookbook name. And what that gives you is a framework, which is basically a folder structure with some predefined files in it. And one of those is a kitchen YAML file. And the kitchen YAML file's responsibility is to drive the test kitchen tool and through the driver, which is the Azure driver, through the converging phase, which is we're going to use Chef Client to converge, and then through the testing phase, which we're using inspec for. And so this is the configuration file that's used. And you can see in this configuration file, first of all, if I go here and type kitchen list, we will see that I've defined three different instances for this sort of session. So I've got a Windows 2016, a Windows Nano, and an Ubuntu 14.04. I decided to create and converge the top two, but not do the bottom one, because I thought you would want to see the sort of the whole process from through those 4 steps. So first of all, we will type kitchen create. Just going to do this manually. So you can type kitchen test, which does the whole thing sort of in one step. I'm going to just convert. I'm going to create one of these machines, which is my Ubuntu machine. Just turn it down a bit. And so the background to this was, I was actually at the PowerShell Summit in Stockholm, and Steve Morawski came up to me. Everyone know who Steve Morawski? Got half the blue shirts in the room, sort of definitely know. Steve Morawski, and he came up to me and said, "Oh, we really need a test kitchen driver for Azure." And I said, "Right, I'm on it." And then pretty much by the end of that week, we had something sort of up and running. So that's off in the background. Let's have a look at the sort of the config. So in our kitchen YAML file, we specify a driver name, which is Azure Resource Manager. We specify a subscription ID. The subscription ID comes from the Azure portal. Who's using Azure in the room? Sorry, I forgot to ask that question earlier. Yeah, okay, so a good number of you. So you know where to find your subscriptions, which just confuses me now because it's not in order. I can't remember icons. I need sort of letters as well. But in your subscription, you can sort of pick out your subscription ID. We have the ability to then specify the location for where the server is going to be spun up, and the machine size. So I've gone for some F2 sizes. So something new I discovered the other day. Who has exceeded the limit of their subscription at any one time with the number of cores? So what type of servers are you using on Azure? What size? So a D size or a D2? Yeah. So one thing I learned this week by mistake, I suppose, was that if you use different types, so I'm using the F series here because they got announced a while back. It looked like they have a better sort of use, better proportion of usage, disk versus RAM, and so I thought, I'll switch all my dev environment to standard F2s, hit the 10 core limit. I was like, hold on, I phoned up about this ages ago, and I went back and looked at the ticket, and the ticket applies to a certain type of machine. So if you move from a D series to an F series, beware, you will hit your core limit very quickly. So it's worth sort of going back and checking that. We specified 3 platforms in the list: Windows 2016, Windows Nano, and Ubuntu 14.04. And the only thing I need to actually configure this is this thing called an image URN. And the image URN, who's familiar with Azure Resource Manager in the room? Who's busy writing sort of templates? So in Resource Manager, you get to specify for a type of compute resource, the publisher name, the offer, the SKU, and the version. And we can use PowerShell or the Azure CLI or the Docker image with another version of the Azure CLI. There's all manner of tools you can use to get access to these image URNs, which are basically just the four parts. So publisher, offer, SKU, and the version. And one of the really good things about that is that some distributions are putting up sort of nightly builds of their Linux distribution up onto Azure, and you can actually schedule a nightly build. I've got something running that's testing, that spins up Test Kitchen with the nightly build of FreeBSD, which is the sort of Microsoft, the Microsoft version of FreeBSD that they're sort of working on. Applies my Chef client, does some testing, shuts it down. Now, to get from that platform list into something real, then we need that driver. What's going on in the background here? It stopped halfway. That's interesting. Let's run it again because it will pick up from where it left off. He says, hopefully. But you can see the output here just looks like the normal output you would get if you triggered the creation of a VM. But actually what's going on here is we've created a resource group for each of those VMs and isolated the I go into here, classic ones. So we've got 3 VMs called VM, which isn't all that useful to us. But hey, we're not in here very often. God, this is too small when I'm here. My resource groups can move at the top. When we did Kitchen Create, so these two I built last night. I just ran Kitchen Create on them. We got ourselves a resource group for each one, and a resource group specifies is a container for the life cycle of the components that are within it, which makes it really sort of suitable for test cycles like this. Because we can say, right, give me a VM, give me a NIC, attach a public IP to it, put the public IP on a VNet, and put the hard disks for the VM in this storage account. And with the source being that the image URN, which is passed in. And what does it get passed to? Well, it gets... Okay, it did finish in the end. Let's open up a new one of these. Open up a code window. You'll see sort of how simple the driver is. If it appears. So the driver fundamentally is two Ruby files, one which sort of does the sort of horrendous mechanism of it has two primary methods, which is create and destroy, and that's all we need to deal with in the driver. And because we pass in the image publisher offer SKU inversion, we then, believe it or not, embedded in here is an ARM template that takes those parameters. And it just differs the parameters according to whether it's a Linux type of machine, whether it's a nano server type of machine, in which case we don't need to run extra WinRM configuration afterwards because it's pre-configured for WinRM, or a Linux machine. So with that in mind, so we now, if I run kitchen list again, so we can see our Ubuntu machine got created, and we've converged the other two. So let's have a look at the cookbook structure now. So cookbooks basically are a folder that contain a folder called recipes, and inside recipes are the chef DSL recipes that instruct the system what to do. And Chef Client operates in two phases, so it calculates all the resources that need to be applied, attaches things like attributes and any sort of substitutions it needs to do, and any logic it needs to apply. And then eventually we get this resource list that is a list of instructions that happen in order, and then the Chef Client goes away and executes all those things in order. That's the basic sort of premise behind it. At the bottom of my kitchen YAML, by the way, I had we specified this thing called a run list, which is the well, it's pretty much as it says, it's a list of recipes to run in order. So we're saying from our cookbook DSC core, run the default recipe, and correspondingly we have a default recipe here, which is completely commented out at the moment. And this allowed me to run something, so I could kitchen converge Ubuntu, just to show you the process that that Test Kitchen goes through. Running from my machine, it will now connect to that Ubuntu instance that got created over SSH. It will then run what's called the Omnibus installer, which is sort of Chef's sort of installer, and it'll put the latest version of the Chef client on that machine. It'll then transfer all the cookbooks that I've got running in that folder locally on my machine over to the VM, and then it will run whatever recipes are in that run list. At the moment, it's just running that default recipe, which is all completely commented out. So let's kind of just follow along for a minute whilst it does that. It's pretty quick, normally. The neat thing about that, is that it's pretty, it's clientless. You don't need any sort of tools installed on those images to start off with. Kitchen provides all the tooling necessary to deploy stuff onto the machine, which I think is, if you compare it with kind of where we're starting on, and in fact where we might finish today with DSC. DSC on Linux currently requires you to install a bunch of packages, install OMI of whatever distribution or distribution or package type you're interested in, then install the DSC package, which is actually a bunch of Python scripts that land in a certain place on the machine, and that's before you even get to sort of the PowerShell installer. So I still think, in the realms of developing infrastructure as code, tools like Test Kitchen, along with the Chef toolset have a massive sort of part to play, and so. When you talk about the open sort of ecosystem, I was saying, earlier, the Chef and Microsoft are, sort of edging closer and closer with their sort of integrations. Right, so we got to the end of the first converge. It said it converged 0 resources. That was basically because I asked it to run a recipe with no resources in it. I commented them all out. So then what was I playing with? Sort of over the last, in fact, it started ages ago, and then this week I decided that I was going to update my my PowerShell recipe. This is alpha, PowerShell Core 6 on Linux is alpha, so I wasn't sort of too bothered about it sort of working or not. But what I thought I'd do was get that installed, and let's see what it sort of looks like from the perspective of Chef. So I'm going to just uncomment this. Can everyone see that? Turn that up. Turn this down. So these are just simple case statements. So when we're Ubuntu or Debian, we want to include the recipe install deb for a deb package. And when we're CentOS, Red Hat, Oracle, SUSE, we install RPM. When we're Windows, kind of do some, is the name of the machine going to be Nano? We'll install Nano because we're still not correctly detecting the platform properly. The other recipes in here. So if I follow this through for the Ubuntu case, install deb. Basically, and this, by the way, is not great Chef development because you would externalize things like the file names and the versions into attributes, but what I just wanted to sort of demonstrate what Chef DSL looks like and how it can be used to help really in the process of getting DSC onto machines. So this goes and gets the OMI deb, runs dpkg against it, then it installs DSC. Similar thing. It has to go and get it from the releases page on GitHub, and then it installs. And then we're going to install PowerShell, and then we're going to run then we're going to get the libunwind8 and libicu52 packages and deploy them using apt as an example. So let's go ahead and, in fact, let's go ahead and do all of this. The next bit after that is that I've got here. So Chef and DSC have a bit of history. So for about 2 years now on Windows, you've been able to define. If I have a look at a typical Windows recipe, this is DSC script. This is baked into the Chef client. And basically allows you to execute, pieces of configuration through DSC processing via the Chef client. And so before this talk, I thought, well, how could we replicate that in the Linux world? So what I came up with was a DSC script NX resource, because for some reason, and it's probably one. The PowerShell the hardcore PowerShell people in the room can tell me why we use different prefixes for DSC across different platforms. No? Yeah. Is it? I would assume so. I guess it's. My first thought was that it must be to avoid customer confusion, and I thought, well, actually, the thing that I would like to see in the end is you should be able to use the same DSL, whether across which platform it was. So I'm thinking, why am I sat here sort of writing this when it shouldn't really be writing code to go down different paths. The platform should be doing it for me. And so hopefully one day we'll see the sort of platform sort that out. But I just wanted to sort of pull up side by side what we're trying to do here. So we've got the Windows version, which just creates an example file, which is about, well, okay, it's not the extent of my DSC knowledge, but it's it's something simple that we can do. And then we've got the same that runs on NX file. What I'm going to do is just converge. First of all, did I save that file? Yes, I did. I'm going to converge that Ubuntu machine again. So you can see we made a very small change. Well, I'll say a small change. I haven't commented a whole bunch of stuff. But then we can rerun the command again, and it will redeploy that cookbook over SSH onto the machine. This time, we don't need to install a Chef client. We've already got a Chef client there running, ready on the machine. We can then use that Chef client, there it is. It's transferring now. We use the Chef client, execute our recipes, and then we can sort of come on to the next bit. So now I've got 8 resources. So this is it's pulling down the OMI. It ran the install on OMI. Similar thing for DSC. Similar thing for PowerShell. And now we're running our custom DSC script NX, which is my sort of just custom version of running DSC, which hopefully will run on a Linux platform. So, and what that has actually done, that's okay, getting a warning that what I've done is really bad and will be removed in the next release. But what we have now is a system that is in a state that we can test. So if you look at the tests we've got defined, so tests, you can set the location of these tests within that kitchen YAML if you wish. The default location for them is in the folder relative to where you're running kitchen from, in a folder called test integration and default. So I've got a set of core tests here. So this, unless, sort of a Rubyism, unless. Does anyone like it? Unless? I kind of like it sometimes. Describe file, temp example, its content should match, and then that was what we put in that DSC script. And if it's Windows, check C example text, its content should match PowerShell Conference Asia. And we can build up within our cookbook, and this is an important point actually, that you want to build up the tests at the same time as your recipes, and ideally you would do them first. This is obviously a very contrived example to sort of get things working as a bit of a technology demonstrator, really, because we're working with alpha stuff. I then got a DSC verification, OMI DSC verification test, checks whether I actually did deploy an OMI server and whether I have. So in DSC on Linux, there's a folder with all the Python scripts, and there's like get DSC configuration, is one of them, and I'm just measuring here. Does this exist? Now I've got the same sort of PowerShell. You can describe a command's output. So describe a command PowerShell -command PS version table.
its standard out should match, and then we can do regular expression matching against, does it say PS Edition Core, is it 6.0 Alpha, and so on. And no, don't stop. So now if I run kitchen verify Ubuntu, that will take the tests that are in that folder and use kitchen again. And the thing about InSpec is that it doesn't have a footprint on the remote server. It actually is running the Ruby code locally, but remoting the test to the remote machine over SSH or WinRM. That kind of makes it pretty powerful, because a zero footprint sort of test tool has become sort of quite a requirement these days, because companies don't want to see you modifying VMs with the test tooling on the way to production. So it runs pretty quickly. So this ran over SSH. Yeah, our file matched. Temp example should match PowerShell Conference Asia. My server should exist. Get DSC configuration should exist. And PS version table should match all the right stuff. And if that wasn't enough for you, you can do kitchen login and specify the particular name. This will set up a session. So way back right at the beginning, when I did a kitchen create on Ubuntu, an temporary SSH key was created locally. The public part of that SSH key was added into the Azure driver. The Azure driver then added it to the Resource Manager document. Resource Manager document submitted into Azure, so that it has the SSH key ready for use as soon as you're in there. Of course, you need SSH keys to get access to sudo and all that kind of stuff. But this, I'm kind of not going through lists of different sort of commands here. I'm just purely using the kitchen framework and config, to do this. So what was I doing? PowerShell. So PowerShell at the moment in the alpha phase doesn't really have VT100 support, which could really do with to get the positioning of the cursor correctly, and the sort of colorization. So it doesn't have it. So the sort of odd sort of workarounds. So if I just to sort of prove that really was what was executed. You can do PowerShell minus command, and that'll help you out. If you type PowerShell, all hell breaks loose, and everything appears in the top left cursor position according to your, the size of your buffer and all that sort of stuff. So that was as long as I thought it would take to converge one machine. We've got OMI, DSC, and PowerShell core on Ubuntu. But what if I wanted to test all the other distributions we had in Azure? Now, this is where the sort of story breaks down a little bit. If I go to my config at the moment, you'll see down the bottom, I've actually got all the supported, in quotes, images. So Debian 8, Red Hat 7.2, CentOS 7.1, Oracle Linux 7.2, SUSE Enterprise 12, and all of them currently have issues building with the alpha of PowerShell. So, but as soon as they do, I'll be able to uncomment. As soon as they start working, I'll be able to uncomment these, add any sort of new packages or dependencies that are required, and then instantly I've added a new platform to my test framework. We can start actually building on top of that, if you wish, with DSC either on its own or DSC through my kind of hooky mechanism. The hooky mechanism I was sort of talking about is actually one of the nice features of Chef allows you to define a custom resource that looks exactly like a resource that comes out of the box with Chef. So resources out of the box with Chef are like apt package, and you provide a source and an action like install or remove. Custom resources are, this is like, 40 lines of script, and in the top, to define our resource, we basically say, well, we're providing this resource, DSC script NX. It's got two properties, a name and the code. It has one action, basically, and the action is defined as run. And within that action, you can include other built-in Chef resources. So basically, what I did there explicitly was download the PowerShell Core NX module onto the Linux machine and put it in the path opt Microsoft PowerShell 6 Alpha 11 modules. And the way we get, if we were to rerun this script, you don't want it to do that every time. So the way we make this script idempotent is by adding this thing called a guard in Chef. So not if this directory exists, and the directory we're looking for is the modules. And I've explicitly called out everything in here individually, so that there's no, I'm not hiding stuff away. Then we create a PowerShell file on a disk with the configuration. Configuration is a merging, basically, of just of a script-based configuration, node localhost. Going to substitute in the configuration code. Yeah, we should be able to put in, up here something about the additional packages needed and all that sort of stuff, but demo. Then we execute PowerShell to generate them off, and then use the Python start DSC configuration script, passing in the configuration moth, which then executes that configuration on that machine. And so it's in localhost. I haven't had to create the moth locally and transfer it into the machine and execute it that way. So this is a custom resource, and you can put a custom resource within your cookbook and distribute it out to people. So the distribution mechanism used for distributing cookbooks, Chef has a gallery as well, which is called the supermarket, of course, being food related. What we'll do is get cookbooks like this, hopefully better ones that have been sort of properly validated and tested. We get them up on the cookbook, and then that's how they're on the supermarket. That's how they're shared across people. Right. So I thought I alt-tabbed out of my deck. However, I didn't. So I'm going to go back to it. Just close up. So, Test Kitchen, I run it locally, both on the Windows 10 client. Also, who's running Bash on the local Windows machine? You can run it there as well. If you can install the Chef DK, just install the dev package, and then you've got access to everything there. It's quite nice. I like it as a developer for Chef. It's kind of quite nice to isolate some of the demo stuff I'm working on and some of the development stuff I'm working on. We use the Azure Resource Manager driver, so it allows us to spin up our instances from images that are already there in the cloud. Those other two images, we haven't really got time, but they're the same. What I wanted to do was basically the converge process for that. You saw it just ran the standard Chef client's DSC, which works perfectly. Chef allowed us to automate DSC and PowerShell config sort of cross-platform. We've got that built-in functionality that exists for DSC script, and there's actually a more modern way of expressing that DSC script in proper Chef DSL. That makes it more testable from if you're doing unit testing as opposed to integration testing. So you can actually do unit testing on your chef code using a tool called Chef Spec, which allows you to run unit tests against your recipe code. We built that custom resource to mimic that DSC behavior on the Linux platform and hide away the sort of implementation detail. And we used InSpec, which is a integration testing tool driven from BDD type language. And you should focus on final point really, integration test for the outcomes, so not for code coverage. So we downloaded the deb package and the RPM package. Don't write tests to verify that. Verify the actual outcome, which was that the package got installed. And I've put something up here. So as usual with Chef, there's tons and tons and hours of content you can go through online. You can spin up your own VMs in there and have a play with it. Chef Development Kit, Visual Studio Code, Test Kitchen, the docs, the GitHub location for the Test Kitchen driver. This code is up on my GitHub, so you can sort of pull that down if you wanted to have a play with it. And don't forget to buy the book. That's it. Thank you.